So this is instructional worksheet 3 for Unit 9, our thermodynamics, and this is in our energy unit. Thermal. The term thermal should remind you of heat. Thermal. That prefix should remind you of heat. And heat is a form of energy. This little factoid right here is very important. Heat always transfers from hot to cold. Heat doesn't arise, hot air rises. So heat transfers from hot to cold. This will be on every version of your assessment. So if I have an object at 25 degrees Celsius, it'll transfer to my 5 degrees Celsius. Insulators slow down heat transfer. Materials with air pockets are good insulator. So you might have styrofoam, that's a good insulator. You might have fiberglass insulation. You've seen the pink insulation or yellow insulation you use in your homes. Some of you might have seen that. Air in windows are good insulators, like if you have a double paned or a triple paned glass. Paned window. Those cushions of air or those layers of air are good insulators. A conductor allows heat transfers, so most metals are good conductors, like aluminum, iron. Those would all be good conductors. Okay, so let's talk about this. Thermal energy, heat, can be transferred by conduction, convection, and radiation. Conduction, convection, and radiation. These are the three ways heat can be transferred. Conduction transfers heat when objects are in contact with each other. We know that kinetic energy is energy of motion, and all atoms are moving, which means they have kinetic energy. Hot atoms have more energy than cold atoms, and when hot atoms bump into cold atoms, they transfer that energy. Heat transfer will continue until an object comes to thermal equilibrium. That means they're at the same temperature. So closer atoms mean more collisions, so solids transfer heat better than liquids or gases. Gases can make good good insulators. Water sometimes can speed up conduction. That's why when we sweat, the water transfers, or that liquid helps the transfer of heat from our body occur quicker. So hot atoms transfer energy to cold atoms, and when they touch, we call that conduction. Better conductors are solids, better insulators are gases. So many of these little factoids will be on your assessments for this unit. Next, convection transfers heat through moving currents. So you've all heard of convection currents in weather. You've heard of currents. So the sun warms the air, the warm air rises, and then wind happens. And when the air cools, it falls back to the ground. So we can see the hot air rises, and then it cools, and then it rises, and it cools, and it goes into a cycle. Hot liquids rise, and we get convection currents in oceans. Gases transfer heat poorly through conduction or convection. Convection currents speed up thermal transfer. Convection currents can happen in gases or liquids. They can't move in solids because solids are held in a rigid state. So convections is what happens like in a convection oven that blows your air around. It happens for air currents whenever you have wind, and it happens in ocean currents like the Gulf Stream. Third, What other colors do I have here? Do I have a light blue? Okay, that's good enough. Radiation transfers heat through electromagnetic radiation, and this can even occur in empty space. And it's a good thing because this is where we get our energy. All the energy on Earth comes from sun. Space is a vacuum, especially deep space. So radiation can travel through space to the Earth. Radiation is interesting because it transfers heat in all directions, like a 360. No matter if you could have a light bulb suspended in the middle of the room, no matter where you stood and observed that light bulb, you'd see the light coming from it. Radiation is the only thing that doesn't require any contact of any particles. Radiation can go through transparent materials like glass. Radiation transfers heat through something called electromagnetic radiation. Here's one other thing that you know. Dark objects absorb more radiation than light objects, and dull objects absorb more radiation than shiny. So a dark object has high absorption of radiation. It heats up fast. What heats up faster on a hot summer day? A dark colored car or a white or silver car? The dark colored car. White or light colors or shiny have low absorption. They heat up more slowly. Now let's start this part, and let's start with these matching. We have heat transfer through electromagnetic rays. Our options are conduction, thermal equilibrium, radiation, wind, convection, and thermodynamics. Please notice that 4 got cut off a little bit, but no big deal. So heat transfer through electromagnetic waves is radiation. A goes with radiation. So when we have heat transfer by objects that are touching, that is conduction. The transfer of heat by moving currents in liquids and gases was convection. When two objects are at the same temperature, that means they have come to thermal equilibrium. The study of heat and how it moves, again, is thermodynamics. And what is caused by convection currents? Obviously, by the process of elimination. You can see that that one is F. Next, let's look through this batch. A region of space that contains no matter at all is called is it insulator, conductor, vacuum, solid, liquid, or gas? And the absence of anything is called a vacuum. This allows convection, but it is a very good insulator. And that state of matter was a gas. Any material that allows heat to move through it easily, we said, was a conductor. Allows convection and can be a good conductor of heat, and that was a liquid. Any material that resists the movement of heat through it, that keeps heat from transferring, is called an insulator. And last but not least, for this set of matching, no convection can occur, and no convection can occur through a solid. Next, let's do our what kind. We're going to label 1 for conduction, 2 for convection, and 3 for radiation. Hot air rises. Well, when we have hot air rising, that is convection. The kind of heat transfers when two objects are in contact or touching. That was conduction. Nothing is touching. When nothing is touching, but we still have a thermal transfer. If there's nothing touching anything, that is a radiation. Atoms collide. And atoms collide, that's going to be a lot of convection. That one you could also argue conduction. The type of thermal transfer that radiates in all direction is radiation. What causes wind? That was convection currents. Between a stove that is in contact with a pot on the stove will be conduction. In a pan of water that we're heating, that'll be convection. More occurs with dark object will be radiation, and through your car's window at night. That will be through your car's window at night. That would be probably a conduction. And that one is another one that you can argue. Let's take a look at this area and find out which of these are at thermal equilibrium. That means they need to be at the same temp. So the two that are at thermal equilibrium are B and C. And all you need to look is at same temp. I want to add one more thing to this. Our transfer will be this direction and this direction in these two. Next, let's draw an arrow for the heat transfer here. And remember, we transfer from higher temp to the lower temp, from higher to lower. So here our transfer will be this direction. For this one, our transfer is this direction, lowered, higher to lower, and higher to lower. So I've got one pointing in every direction. Then we're going to label I for insulator and C for conductor. Remember, anything that is made out of a metal is a conductor. So a metal is a conductor, a penny is metal, and aluminum is metal. So the rest of these, this is sort of interesting. A glass can be either. Sometimes it acts as an insulator, sometimes it acts as a conductor. So I'm going to give that an either because I don't love that question. Water can also be either, but it's probably more of a conductor. Wood is an insulator. Air, we said, was an insulator. A coat that keeps you warm is an insulator. And styrofoam is an insulator. Next, we're going to label A for absorbs heat, heats up quickly, or reflects heat, heats up slowly. Anything that's dark or dull will be a reflector. Dark liquids, dull objects, black paper, and a dark car. If it is shiny, oh, I did that wrong. My bad. Absorbs heat, that would be dark and dull. This would be light and shiny. Okay, so my light and shiny will be reflects, 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 reflects. Okay, and then absorbs heat will be my dark and dull. A dark car. A styrofoam, that's a hard one. That's going to heat slowly. So this is a hard one. So I'm going to put a question mark by that. Does heat rise? And you're going to be tempted to say yes, but the answer is no. Heat doesn't rise. Hot air rises. Yes. Hot air is less dense than cold air. And because hot air is less dense than cold air, hot air will rise. Then we're going to talk, is this diagram correct or not? No, it is not correct. And we know that because heat always transfers from warmer to cooler temperatures. It always does a transfer from warmer to cooler temperatures. Okay, make sure that you've got everything down really well on this. It is the instructor's choice to collect if you're not participating on this, or to put in your notes tab in your binder. So make sure that you're getting your stuff done here. And that should be good on this one.